Okay, on this one we have a fourth degree polynomial, and we are trying to find the zeros, or the roots, or another word would be solutions. So that's the values of x that would go in each one of these x's and make this equation equal to 0. So what I've done is I have taken the coefficients and written them here. And what we're going to do is we're going to guess some possible roots to this equation. Well, we know this. We know that the roots of this equation should divide this last number 50. And if there were fractions, the denominators of the roots would have to divide this number 1. Well, this one's not too bad, because this, being that the first number is a 1, that tells me that none of my possible rational roots will be a fraction. So I say anything about numbers that divide 50. And, the first one that comes to mind for me is the number 1. So I put a 1 there, and I take this 1 here and I bring it straight down. Now, then what we're going to do is we're going to take the 1 on the outside here. I'll make it a different color. We're going to take the blue 1 and we're going to multiply it times this red 1 that I dragged down. So 1 times 1 is 1, and I put it right there. Sometimes I draw the bar here, sometimes I draw this bar down here. It's all the same. Okay, so now I'm going to take this -7 that we got from our coefficient. I'm going to add it to the 1 that's right here, and that's going to give me a -6. Okay, the next thing I'm going to do is I'm going to multiply again. I go back to the blue 1 over here, and I'm going to multiply it times -6, and that gives me a -6. Now a -3 plus a -6 is a -9. And a 1, blue 1 again, times -9 is -9. Okay, this is going to give us a positive 46. And again, the blue 1 times 46 is 46. And I think you can see that 50 plus 46, this value here is what you get if you plug in a 1 to this equation. Because what we did down here was just a fancy way of plugging in 1 to each one of these x's. And since this does not equal 96, that tells me that that answer is not correct. So let's just go through and erase all those. I'll just grab all those and I'll delete them. Okay, because that did not work. All right, well, let's think of another number we could try. Well, if positive 1 divides 50, we could also try -1. So let's try that. Okay, so we're going to try -1 this time. I bring down this 1 here, comes straight down, and then we multiply. And I get -1, which gives me a -8, which gives me an 8, which gives me a 5 when I add. -3 plus 8 is 5, and then -5 here. And then 55 minus 5 is, well, that's 50. And then 50 times -1 is -50. And 50 plus -50 is 0. Well, that's great news. It's great news because we have found that one of our solutions, I can even put it in a solution set, one of our solutions is a -1. And this does more than just give me the answer, though. It also tells me how to factor, because those are the coefficients of the new polynomial after I divide by x plus 1. So if x equals -1 as a solution, that tells me that x plus 1. Notice the opposite of that, right? Because it has to be what makes, when you solve it equal to 0, what gets you -1? Well, that would be x plus 1, right? If I put in a -1 for x in this factor, I get -1 plus 1. Well, that's 0. So that would equal, that times anything would equal 0. Now, these are the coefficients. Now, earlier we had x to the 4th, then x to the 3rd, then x to the 2nd, then x. So now we're going to start at x to the 3rd because we brought it down by 1 level. So I have 1x to the 3rd minus 8x squared plus 50x, plus 5x, excuse me, and then we have plus 50. Okay, well that's good. All right, now what would be really nice is if this cubic were groupable. But if you look at the coefficients on the x cubed and x squared, this is 1x cubed to -8. They'd have to be in that same ratio. So this would have to be like a 5 and then like a -40 where you'd multiplied it by -8. So we're going to have to continue this process of guessing and checking again. So I'm going to make a new little synthetic division house here. We're going to start this process over. Earlier we tried a +1, and that didn't work earlier, so it's not going to work now. So we're going to try another one. Okay, let's see. Well, we could try -1 again. We haven't ruled out that it happens twice. But I don't think I'm going to do that one. I think I would like to try maybe a -2. Let's see what that does. Let's try a -2. And I'm trying this because I saw that -8 and -2 would give me a -10, and that gave me a good feeling. I don't know if this will work or not, but I felt like that might work there. So when I multiply it, -2 times 1 gave me -2. Now -2 times -10, that's +20. And I think my intuition serves me well because it looks like I got it on the first try. But remember, it doesn't matter if you get it on the first try or not. It doesn't take long to do this. You just need to try all the things that divide 50. And so yeah, that's 1, 2, 5, 10, 25. But numbers like 25 are very unlikely to be zeros because they're so big. It would be very unlikely for them to be zeros. Not impossible, just unlikely. Okay, well as you can see, when you plug in -2, you get 0. So I'm going to add that before I forget to my list up here. Okay, now I got 2 colors in my solution set, but that's okay. All right, let's take a look now what we have. Well, now we know we still have that this x plus 1 was a factor. We know that. We get to add to that a new factor that we found that is x plus 2, because -2 is a 0, and -2, if I put it in for x, -2 plus 2 would give me 0, and 0 times any of these other factors is 0. And this is nice. It gives us x squared, because remember we were at x cubed. We go down a level to x squared. Now it's minus 10x, and then plus 25. Okay, now at this point, I'm going to try and factor this by conventional means, and if I can't do that, I will just simply use the quadratic formula. This is factorable as x minus 5 times x minus 5. So I'm going to call it x minus 5 squared. So we've got this polynomial completely factored. We now know all of the roots because we already knew 2 of them, and the root of x minus 5 is 5. So that whole polynomial equaled that. I'll just keep that equal 0 to remember. I should have written that each time to be absolutely precise. Okay, so our final answers are the zeros of each of these factors. And 5. And technically, just to point this out, technically we got the answer 5 twice. The fundamental theorem of algebra says that we should get 4 zeros for a polynomial of degree 4, and we really did because we had the x minus 5 twice. It was what we call a repeated root. And that's it for this one.